All right, everybody, it is time to turn our attention to Lesson 62, where we are going to focus on displaying data in stem and leaf plots and histograms. Now, I know we just did the lab on how to create histograms with our graphing calculators, and we're going to continue a little bit of that today. I honestly don't know how much of this you'll see over your lifetime, but in any case, we will look at some of it today. Hopefully, you have worked through your warm-up for Lesson 62, and you observed that the sum of values in a data set divided by the number of data values gives the mean. That was the answer to number 1. And then you found the mean, the median, the mode, and the range for the values listed in your warm-up problems number 2 and 3. I just want to remind you that the mean is the average of all of the values. The median is the value that is in the center of all of the values that you are working with in a given problem. The mode is the value that shows up the most often, and the range is the spread between the highest and the lowest values that you have in any given data set. So we're going to talk today about how to display that data in 2 different forms, a stem and leaf plot and a histogram. I don't think either one of these are foreign to you. This is probably not the first time you've seen them, so we're just going to have a little bit of fun with them today and work through displaying this data in our stem and leaf plot and in a histogram. Okay? So the first thing that we have here is a list of data, a list of ages of dance instructors. Now, in order to create a stem and leaf plot here of the ages of these dance instructors, we need to figure out what the stem is going to be and then what the leaves are going to be. So let's look at our data, and it looks like I have all of the data values that I have are 2-digit numbers. They all have a number in the tens place and they all have a number in the ones place. So our stems are going to be the numbers in the tens places, and our leaves are going to be the numbers in the ones places. We don't have any zeros in our tens, so the lowest value that we have in terms of our stem is a 1. Okay, so we've got 1, 10, and now we've got to look through and figure out where those are. So I've got a 19 and I've got a 17, and I want to put those in ascending order. So I have a 7, a leaf that's a 7, and a leaf that is a 9. Okay, so I took care of those. Of course, this would be easier if I took the time to put these all in order, right? Then I would see them pretty clearly. So hopefully I don't miss any here. You certainly could arrange these values in order, but now let's look at all of the values that we have here, the ages that we have here, that have a 2 in the tens place. Okay, and let's see, do we have any 21s? Let's see, I've got a 25, a 24, 28, 29, 26, 27, 29. All right, I'm just going to go ahead and write those. I'm going to write those down over here so I don't lose track of any of them. Okay, so I have a 24, I have a 25, 26, a 27. A couple of those repeated, right? I had a couple 29s, so I've got a 28, and then a 29 here, and a 29 here. One thing that's important to remember when I have repeated values in a stem and leaf plot is that every single value needs to be represented here. Okay, so I have, for my leaves, I've got a 4, a 5, 6, 7, right? 4, 5, 6, 7, and then 8, 9, 9. 8, 9, 9. So a lot of leaves there on that 2 stem, representing the 20s. Okay, for 30s now, looks like I've got a 32, 34. Did I have any 33s in there? I don't think so. Another 34. It's a 40, 50, 40. Here's my 38. All right, so the leaves that I have on my 3 stem include 2, 4, 4, and 8. And I need a 4 stem. I've got a 48, a 47. Oh, did I forget a 38? Uh-oh. Hold on a sec, guys. Did I just not cross that out? I think I just didn't cross it out. Yeah, I just didn't cross it out. Okay. I've got a 48 here. What else do I have in the 40s? A 47. That's it. So I've got a 7 and an 8 leaf there on my 4 stem, and then I've got, make sure, go through those values. I've only got one left right here, 58. The key helps me know what I'm looking at. So I can pick any stem that I want and make sure I pick a leaf on there. So I'll just go ahead and pick the 4, and this tells me, as I write this down, that if I see a 4 and an 8, that is the equivalent of 48 years. That helps me know how to interpret my stem and leaf plot, okay? Now, using the data from number 1 here, I've got my stem and my leaves of the age of dance instructors, okay? Using the data, I want to find the median, the mode, the range, and the relative frequency. I'm not sure if you guys have talked about relative frequency before. It's not difficult though, so we'll touch on it today. If you have any questions about it, ask Mrs. Bryden, but let's get to work on finding these one at a time, and I think this will make sense as we get to it. So median, to find the median, we want to find the middle value or values. It depends on how many we have. The leaves represent how many values we have in the data set. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Because I have an even number, I know that whatever the 8th value is directly in the center. So that 8, there'll be 7 to the left of it and 7 to the right. So that's the median, right? So if I go 1, 2, 3, 4, 5, 6, 7, 8, if I do that here, that should give me a median of 29, but I need to make sure 1, 2, 3, 4, 5, 6, 7, 8, that I've got 8 on the other side too. 1, 2, 3, 4, 5, 6, 7, 8, and I do. Okay, so that median there is 29. 29. Okay, that's the middle value or middle values here. The mode are the value or values that occur most frequently. Now, if there are no values that occur more than once, then there's no mode, okay? But if there are value or values that occur the most frequently, we have to figure out, are there some that occur the most frequently? Then we recognize those as the mode. So I only have 117 and 119, but check this out. I can see I've got 229. Stem and leaf plots are so helpful for this. And I've got 2 34s. So those are my 2 values that occur most frequently, right? So I've got 29 and 34. The range is the difference between the greatest and the least value in the set. Now again, stem and leaf plot, super helpful for this because I can easily see that the greatest value is 58 and the least value is 17. So when I do that subtraction, the difference between those is 41 years. Now, relative frequency is the number of times an event happens divided by the total number of trials, okay? So they want to know, what is the relative frequency of 34? What's the relative frequency of 34? Now, I've got, how many 34s do I have? I've got 2 of them. So I got 2 34s, and how many total pieces of information, how many total values do I have in my data set? And the answer, do you remember? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I've got 16 total. So 34 shows up 2 out of 16 times. I reduce that to 1/8, right? And when I do my division, if I were to put this in my calculator, I just happen to know that 1 divided by 8 is 0.125, right? Let's check that. Yep. So this is equivalent to 12.5%. Okay, so the relative frequency of 34, the frequency with which 34 shows up in this data set is 12.5% of the time. And I did that by dividing the number of times 34 showed up by the total number of values that I had in the data set. Now, the next thing that we want to do in this lesson is to create a histogram from this data, okay? I had to delete the frame that you had in here because it didn't translate well, so let's just go ahead and draw together a nice rectangle. Okay, and these are going to be the dance instructor ages. And then on this side is the number of instructors. Okay, the number of instructors. So I've got now, okay, the ages are going to go here, the number of instructors are going to go here, okay? So I'm going to start with my histogram, and we remember that a histogram is a way that we display data in equal intervals, okay? It shows a distribution of data. It doesn't tell us anything else about it, but I can put my minimum age here. Since I've got a stem of 1, I'm going to put my minimum age here of 10. I don't have any dance instructors who are going to be under the age of 10. Thank goodness, right? My next interval, and they have to be equal intervals, so let's make it 20, 30, 40, 50, and 60. Now, the number of instructors within each one of these age spreads, okay, I can see fairly easily. I've got 2 that are in between 10 and 20. I've got 1, 2, 3, 4, 5, 6, 7 that are in between 20 and 30. 4 that are in between 30 and 40. 2 that are in between 40 and 50. And 1 that's between 50 and 60. So when I put the scale here, okay, on my y-axis, in terms of the number of instructors, the most I had was 7, right? So I'm going to go ahead and make my scale here in 2s. I'm going to set this at 2, 4, 6, 8. I never have more than that, okay? And I'm going to do the best I can to just draw a straight line across to show that. This line got a little messed up, sorry, got a little high. A little better. And that's going to help me plot the distribution of the data. Okay, now I've got 2 instructors that are between the ages of 10 and 20. Remember, this is a 2. I better mark that, huh? 2, 4, 6, and 8. So I have 2 that are between the ages of 10 and 20. So I'm going to go like this and just go ahead and fill that in. 2 instructors between 10 and 20. Between 20 and 30, I've got 1, 2, 3, 4, 5, 6, 7. So that's going to hit right in between here and here and show me. So I'm going to go ahead and draw a line here and here. And remember, these are equal intervals, so I should have no spaces in between these bars. Okay, so it's going to show me I've got 7 instructors between the ages of 20 and 30. 1, 2, 3, 4 instructors between 30 and 40, so that's going to hit right here. Just kind of gently shade that in so I can see that. Okay. Between 40 and 50, I've got 2. Again, here's my 2 line. And between 50 and 60, I have 1. 1 instructor between 50 and 60. Okay, so that is what my histogram looks like. And again, it shows me the distribution of the data, but it doesn't tell me anything other than that. Okay, now let's remember how to create a histogram with our graphing calculator. So go ahead and turn, if you would, in your book, just like your notes tell you, to example number 4 on page 408. Okay, on page 408. I'm going to change what we're doing here, so don't worry too much about this one. This one we're just going to do, you don't have to write anything down. We're going to just go ahead and enter these values in from example 4 where it says application sports. And we read, the list below shows the results in meters in the first round triple jump from the 2007 NCAA Women's Outdoor Track Championships. Create a histogram of the data using a graphing calculator. Okay, so we just created a histogram by hand. We took our stem and leaf plot and we essentially sort of just shifted it, right? We turned it this way. This stem and leaf plot, in essence, is just here, where we can see, okay, where the stems and where the leaves are, but we can also do it on our calculators. And that is what we did in our lab, and we're going to do it again here with these values that we have from this NCAA Women's Outdoor Track Championship. It's a lot of values. So the very first thing we need to do, now if you have this many values, I would definitely recommend using a graphing calculator if you're given an assignment like this, but we have to remember how to do it. So first thing first, we need to remember how to get to the list, right? Okay, so I'm going to actually, let's see if I can remember it off the top of my head. Okay, if I go to stat, push stat, and then enter, fantastic. Now I've got a list. I want to make sure I go all the way up to L1. If I have any values in there, I need to clear them out. And I just kind of keep pushing clear. When I push my up and down buttons, that's when they all disappear. So take a second to do that. If you have any values in your list, in your L1, clear them out. I just want to show you that one more time. Okay, so if I go to statistics, this stat, I'm on number 1, edit, I hit enter. Let me just move my calculator up just the tiniest bit. And I have now L1, okay, list 1. What I'm going to do now is I'm going to enter in these millions of data, this data set here, okay. The first number that I'm looking at is 12.16, 12.16, enter. Next value, 11.77, enter. Next value, 11.64, enter. Next value, 11.50, 11.5 is fine for the calculator, hit enter. 11.48 is next, enter. 11.45, enter. 11.31, enter. 10.94, enter. 10.98, enter. 9.88, enter. 12.08, enter. 11.58, enter. 11.41, enter. 11.5, enter. 11.34, enter. We're almost there. 11.24, enter. 11.22, enter. 11.13, and the last one, 10.76, 10.76, enter. Okay, now that I've got all 20 of those values entered in here, okay, I'm going to go to the stat plot screen, which is second y equals. See that stat plot right above there? So I go second y equals, okay. I want it to be on the histogram plot, so I want it to be on plot 1. That's all good. Hit enter. If you're on plot 1, hit enter. I want it to be blinking on, so that's good. Okay, I can hit enter right there. Just make sure that's on. Use your down key here for your arrows, and the type that we're looking for is that one right there in your first row. You want it to be the last one, that little tiny picture of a histogram. Okay, make sure that you selected that, and your X list is at L1 and your frequency is at L1. Okay, now we want to make sure that our window, if I go to window, I want my window to line up here with what I've got, these window intervals. So the x minimum should be 9. The x maximum should be 13. The x scale should be 1. Y minimum should be 0, which it is on mine right now. The y maximum is 15. The x scale is 5. And x res is 1. Okay, great. So now I've got all of those things displaying correctly. Okay, if I go to zoom now and I hit number 9 to put that in a standard viewing window, then I've got my histogram. All right. Okay, now the trace functions, we learned these things in our lab where we learned how to trace. We learned when we hit that button there, it showed us our minimum, our maximum, shows us our n number, meaning the number of values within each one of these data ranges. Again, the histogram is showing us the distribution of data, and that's all it shows us, okay? So it's showing us where the numbers line up in terms of the numbers of values that are within each one of these equal data ranges. Okay, guys, hopefully your histogram looks about like that. Now the last thing that we have to do, I'm actually going to change this for you, okay? I'd like for you to move on now to the practice problems here. This DE stands for dry erase, okay? And on your dry erase boards, and you can do this with a partner or you can do it on your own, either way, but I want you to complete, please, letter C and letter D, and then letter E right here is creating a histogram using a graphing calculator. So instead of doing this, using a graphing calculator, create a histogram for the data in number 1. I'm not going to do that all over again. We just did that. Okay, so, but this one right here, that's essentially what you're doing. Using a graphing calculator, create a histogram for the data in, just cross this off, this, in letter E. Don't worry about how many intervals it makes, okay? Don't worry about that. And then here in your notes, you can go ahead and draw the histogram that your calculator creates. So do C and D on your whiteboards, do E on your graphing calculator, and give me a little sketch in here of that histogram, and I'll check your notes when I get back. I believe in you. If it gets confusing, then go back to the lab that we just did, where we were learning how to draw histograms with your graphing calculator. Go back and just follow it step by step, but use the values from this problem, okay, from letter E, from our practice today. Once you're done with that, if there's still time in class, feel free to move on to your homework, and our homework will be due at our next class period.